Hello everyone, thank you so much for joining in today and very good evening to all. So कैसे हो आप लोग? First let me introduce first let me actually have some sort of greetings from you and yeah, hello Shiv Saran, hi and I'm doing great. How are you? Hello Mansoor, hello Sabiha, I hope yeah Sabiha. I guess I do. Okay and hello Karan, hello Shivratri, hello Saurabh, hello Abhinav, hello Rohan. Hey, hey Yuan. Uh, Ecuador. Wow. Okay. Hello. Good evening, Dhanisham. Good evening, Mega. Hi. Hello, 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 everyone. Okay. And my name is Gopal. First, just don't call me sir. It doesn't really feel good. All right. So just don't do it. My name is Gopal. Please refer me as Gopal. That's it. No, sir. Nothing. Why it is not showing my screen. Okay. Not being able to share my screen. Moderator. What's up? Everything's fine. Tech Coder. Hello, Colorado. Hello. Hi, sir. Hey, Gopal. Hey, Kamarosu. Hey, Abhinav. Again, hi. Okay, so let's get started without wasting a single second. And tablet to go. So today will be all about the introduction of biological neurons and how exactly we can make some sort of analogy with the mathematical functions, like the compound functions. So let's start and let's see or let's explore this very exciting field here. So let me just okay. So up until now, whatever we have seen so far, what exactly we saw? Like we saw general machine learning systems, right? Supervised, unsupervised, and reinforcement learning. And machine learning, like it's great, like it's heavily based upon some heuristics and hypotheses, right? But since we are here and we are studying deep learning, okay. So deep learning is basically a subsection of machine learning. Where deep learning, what exactly the core idea here for the deep learning is, we try to, supposedly, we try to make algorithms which could mimic human brain, literally human brain. But how is the question here? Okay, hi Pyle, hello V Music. Okay, but how is the question here? Okay, and let's actually try to find like the answer to this question. How exactly we can make this happen? So we've got your machine learning. Okay, like this is your machine learning. Let's say this machine learning, and this deep learning is nothing but a section of machine learning, a subsection of machine learning. So whatever we have seen so far, okay, will be applicable for the deep learning part as well. Okay, so let's get started. So, okay, algo data structures are you teaching? No, I'm not teaching algorithm and data structures. No. Okay, so let us see how exactly basically got started, like how exactly this deep learning stuff actually got started. And you may have also heard about ANNs as well, like maybe have you heard a term called neural network? You must have actually heard about this, right? Neural networks. And also ANNs, artificial neural networks, or DNN, deep neural networks, even CNN, convolution neural networks. There are RNN as well. Okay, like then literally we have different kinds of neural networks. Okay, but let's actually stick with the basic one. What exactly the neural network is and why in the first place we are even calling it a neural network. So we have to dig deeper, but not in the mathematical term or like not in the mathematical literature, neither in the machine learning or deep learning literature, rather into the biology, right? Like especially the your cortex system or like your brain, okay, your cognitive system. So if I go back here and if I please change the background color bro, Sure, bro. What should I change? Like, what exactly should I make it as a background color? Just tell me. I can actually change it. Like, let's say white, and I can actually write it with the black. Is it better? Just tell me. Like, is it better? Like, which one is better? And I can also make it somewhat medium. Like, is it looking much better now? Just let me know. All right. So what we are studying right now is like, like this is way too much thicker. Honestly, way too much thicker. It's actually heavy thing, right? Okay. So we've got here neural network. This is something we need to discuss. Okay. So let's go back here. I cannot draw a neural network for sure. So, but in this case, I can search for it, right? So neuron, or I can say biological neuron or neurons, neuron structure. Let's see. All right. And if I go here, hmm, let's actually stick with this one and open this image in new tab. Let's try to understand this. Okay, so this is your structure of a neural, like a neuron basically. This is a neuron, right? And these are called dendrites. So what exactly those are? So let us say right now, like I'm holding this pen. So, and maybe not only this, like let us say if I throw a question at you, which is like 2 plus 2, obviously your brain will just gonna calculate that, like that expression will just gonna return as 4. So that information, that like entire information actually falls firstly here, like in this case, like here, 2 plus 2 on the dendrites. Like that is where it actually got received at. And so your dendrites are nothing but your input gates. So like actually they actually works as an input stream. Okay, and we pass this as an input stream through a sheath or a like a this tunnel called axon. Okay, so like that is where all the calculation actually happens. And after that, on the terminal here, axon terminal, you get your output. Okay, so that is your basic structure of neuron. And there is a there is a concept called given by Jubal and Wiesel, neuron that wires together, fires together. What exactly does it mean? Okay, so similar neuron tends to behave similarly, like that is what it means. And why exactly am I teaching you all of this? Okay, so if we go with the human brain, okay, if we go with the human brain here, neuron structure, adult versus kid versus old. Okay, and if we go back here, if we see here, let us say at birth and open this image in, again in new tab. What exactly is going on? So this is again a neural network structure. Like this is your neural network. Okay, at birth, like basically an infant, right? Like you can see, there are some lesser and lesser connections. I will gonna let you I will gonna teach you like what exactly those connections are. But what exactly they do, like let's say this is a neuron and this is also a neuron. So they both actually gets connected like this. Like they basically with some sort of a wiring system. Okay. So these two neurons are wired together. And this is the structure at birth. Right. After 7 years, like you can see, as you as a human grows older, like there are certain like n number of activities going on in his brain or her brain. So therefore, you can see like there are bunch of neurons, like because like a toddler's brain, or like maybe a 7 year old brain, like it's quite curious, right? It's extremely curious. So therefore, like we are having a lot of wiring here between neurons. And these neurons not are in just hundreds of thousands or like even hundred thousands, like they are in billions. The connection or the connections which we are seeing right now are in billions. And as you grow older, like maybe like an adult, like maybe like 17 to 27, this is an age where you are an adult, right? So some of those neurons must have actually merged together. So you may have actually left some of your activities which you were doing at your when you were actually at the 7 years of age, and as you grew older, you stopped doing it. Like for example, a 7 year old would suck his thumb, maybe possibly, right? So that is what these neurons are for, right? So as you grew older, right? So you literally got out of that habit, right? You stop sucking your thumb, so on and so forth, right? So some of those neurons actually go those connections actually got merged. So this is actually the brain structure, not brain structure, sorry, a neuron structure, like a neuron structure. Okay, and a single neuron is responsible for firing an action. Okay, so how exactly we can actually lay a structure for these neurons? Let's see. So let's say we've got four neurons here. Okay, so I can say here, like let's say these are one, two, three, and four. Okay, and each input can actually go like this, and this. And not only this input can also go here, and this input can also go here. Like these are your neurons, biological neurons. All right. So, and it basically gives you an output in the end, as we saw, like that 2 plus 2 thing. All right. So, how exactly we can make certain, or like I would say, how exactly we can mimic this certain structure with the help of mathematics? Let's try to understand that. Okay, and let us see how linear algebra and even even metrics and everything can actually help us out in order to formulate a neural network. All right, so let us see. So let us say again the very basic task. Let's say if I define the task is here is this: determine housing price, you know, based on mm, locality, age, like how old the house is. Your voice is not clear. Just a second.
How about now? Can you hear me now? Okay. All right. Okay. So now let's see. Okay. So the task is here is to determine a housing price based on these features. So like these are your features. Okay. You've got the locality, you've got the age, And not only this, let us say, size of the house. All right. And mhm, 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 mhm. And also the locality can be also like, okay. And I need actually one more parameter, like 4 actually sounds good. Okay. And I think like what else I can have. Okay, number of bedrooms. Okay, so number of bedrooms is another parameter here which we can tackle at, like tackle with. So let us say like I am naming this as x1, x2, x3, and x4. Why exactly am I doing it? Because it's much easier to write this over and over. It is something for my own convenience. Okay, and now let us say I am laying here x1, x2, x3, and x4. Okay, and let's say here, if I multiply, like if I let's say age and size. Okay, if I consider these two features here, x2 and x3. Okay, age and size. So what exactly it can tell me? Uh, like like let's actually not take this one. So sorry, like for my like no for my mumbling and everything, but because right now I'm just thinking out loud right now. Okay, let's actually go with this one, x1 and x2, locality and age. Okay, and it can literally tell us like how expensive a house can be, right? Okay, and now let's say for x3, and even for the x3, like no sorry, x4 can also be a part of x, and even x3 as well. Okay, like this is the neuron. Okay, like this is a neuron. Let us see like how exactly I am actually making this neuron here. So this neuron is basically determining how much your house will just gonna like price at, like based on these features. Okay, and not only this, the we can also feature engineer, like further, but I have not covered that part yet. Okay, okay, and based on this, what I can determine here, price, right? Okay, so this is something like I know, like you can actually consider this as a neuron. Okay, but this is nothing but a mathematical function, right? A mathematical function, or the additive sum of all features, right? What else I can say here? Price is equals to what? Additive sum of all features, right? So if I have to write the equation of the price, what I can write here will be as follows. Price will be equals to uh, x1 plus x2 plus x3 plus x4. But the question is here, question, will all features will all features going to have same influence on the price, on the house price, I would say? Like, is it true? Like let's say if I add x5 as well, and if I say like and if I say x5 as, let us say for the x5 here is house of the color of the house. Okay, so what my question is here, this x5, so is this feature contributing in the prediction of this house price in a very same way, the way x1, x2, x3, and x4 are doing, like or like contributing? Like, is it true or is it false? This is the question to you. Can you switch to Hindi? It will be more comfortable for all of us, I guess. Definitely, I can switch to Hindi, but you literally made a statement in English. So sorry for that, but like you people are here who maybe like cannot speak in Hindi, right? Like cannot even understand Hindi. So I have to maintain that difference. I have to keep respecting that difference, and I have to continue my rest of my session in English. Okay, so sorry for that. All right, I hope you get it. Okay, so it is a false statement, right? It's a false statement. So how exactly we will gonna determine, like, how exactly we will gonna determine that? So that is where your influence factor actually comes into the picture, which in this case will be which in this case will be a weight factor. Like how much weight each feature will going to contribute in order to make that prediction. So I am just naming that value as W1, W2, W3, and W4. And also let's actually have it as X5, the color of the house as W5. And this W is nothing but your W vector or your weight vector. Okay. So it determines how much each feature will going to influence the price. Influence the price. Sorry for that. Like I'm just writing it really roughly. It's fine, Alok. Okay. Okay. So now if you notice, like from a perspective, like okay, this is something we have. Let's actually reduce the number of features here. Let's only go with the age and the size of the house. And I'm naming this as F1 and F2. Let's actually go with this one. Okay. And not like, okay, let me actually make it much more simpler. Let's only go with the size of the house. One feature only, F is equals to size. So if I have to make an equation out of it, how exactly I can do it? So price can be referred as what? Weight of the size vector or of the size feature. I'm naming that as WF multiplied by F plus some bias. Let me explain what exactly this is. So first thing is here is this is what exactly it is. Like this is weight that will, or I should say, weight which will influence the feature F. Okay, and this bias, what exactly this is? Let's see. Let us see. Okay, let's actually try to understand this. Okay, so let us say you have got this, x and y axes here. This is your x, and this is your y. Sorry. Okay, and now if I go back here, and this is your y, and this is your x. And on x, you have what? The size of the house, right? This is the size. And let us say the size and the y has a linear relationship. Like as we grow the size of the house, right? Price also grows. Okay. So let us say this is the curve which we are having here. Okay. So for each size, like you can see, the price is also growing. Okay. As the size is increasing of a house, price is also going, like increasing, sorry. But since we live in a human world, we are surrounded by humans, so and human error is out to be like out to occur, like it will gonna occur. Okay, but what if due to human error, due to human error, we don't have a size of a house. Let us say in the locality, like in locality A, in your city, okay, locality A, in your city, somewhere in your city, you got to know weird, like size proportion. Let us say like it is like no 333 square meter, and you haven't got no clue, like you've got no clue meter square. You've got no clue like what exactly the price for this will be. Like let us suppose that. Now is the question. But can you say here like this size will gonna have a price of zero? Can we say that? Yes or no? Yes or no? We cannot, because like there is certainly some sort of data here. And if we are not aware of the size at all, like there is no chance like the price will be zero, not at all. If there is a land, there will be a price, right? So therefore and we have to, therefore we have to introduce a bias. Like okay, if I go into a locality A, the minimum price will be there, right? So let's say like the size for this, like this is for the locality A, and you can have n number of localities in your city, right? Like A, B, C, D, E, F, G, H till Z, and each locality will gonna have its own set of like prices. So therefore what you need to do, you need to introduce a bias for each locality, because when you do not have the size value, you can at least say the default value for each locality. Like if I go into the locality A, the default price for that locality is, let's say, $100K. You will not gonna find less than that. That is the bias here. So when I say bias, that is what it means. And this is your weight vector, the weight vector which will gonna influence your feature. In this case, the feature is your size. So if I go back here for this one, for this structure, how exactly I can write it here? Like B as follows, right? Okay, and now the new equation, let me actually redraw this. So we've got here this x1, x2, x3, x4, x5, and b. These are the inputs which we are providing to our neuron here. Like in this case, this is the neuron here, and right. And let us say we are giving it as this with w1, this with w2, this, this, okay, w3, w4, w5, and w6. Let us say if I call this, because it's a function, if you notice, like literally I'm making this neuron, or like literally I'm representing this neuron with the help of a mathematical function. So I'm naming this function as f, and this is literally like this is a single neuron here. And this f can be further, can be like how exactly we can refer this f as w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus w5 x5 plus b. And this will be your f. And this f is your estimation of a price. Is that clear to every one of you? What exactly the neuron is doing in this case, right? Okay, and this is your linear neural network with single neuron, right? Okay, now let's actually further this entirely. So what you have here, you have got this f, your estimation. But like let us say if someone actually comes to me and asks, like let's say, hey Gopal, like can you tell me like, no, what exactly do you mean by Muhammad this bw6, just bw6, oh, thank you so much Muhammad. It will be one, it will be one. Thank you so much Muhammad, thank you so much. Okay, all right. uh, So here we have this estimation f. Estimation is nothing but like your mathematical function, like the way we actually just saw here. It is estimating some like price based on the parameters which we just provided. Okay, and now the question actually you should ask, question is here, how much this estimation is correct, right? Is correct. I can like my model can literally output anything. My model can literally spit anything in this case, right? But how, like how much it is true? Like that is the, that is something we actually, like looking for, like how accurate our estimation is, right? I hope this is the, this is the clear picture to you. Okay, so what if let us say I've got here this estimation. Let us say if I estimate 100K dollars, and the original price of that house will be, let's say, 150K dollars. So the estimation, so the error, what exactly the error here will be? 50K. And like there will be negative 50K, so like you literally estimated negatively, that therefore like it will be negative here, right? I hope this is clear. Okay, so what if let us say like this is the error here. Okay, I'm just gonna make this error as a squared error. So what your squared error will be? Your, estimated error, estimated, the price minus original price, ka square. This is a single error. Okay, and let us say if I have this xy axis here, okay, if I have this xy axis here, and if I plot this value here like this, and let us say like, okay, and this axis, like let us say this axis has an equation of y is equals to mx plus c. Let us say like this is the equation. And if you are aware of little bit of Cartesian, like if you do have the knowledge of Cartesian system, right? Like the equation, like if I have the point for this and this, like if I have got this point P1 and P2, right? And each P1 and P2 will gonna have x1 and y1 coordinates. Okay, and this equation can have literally infinite number of x and y coordinates. Yes or no? Right, so each, like on this line, each will is going to have x and y coordinates, right? And if I say here like this is your y and this is your x, and let us say now each estimation, now the mechanism. So here I'm writing the idea here. Idea is this, uh, project estimation for xy plane. Okay, like how? Keeping keeping x same and y to be estimated. Focus, guys. Okay, and now let's say if I, like, let me actually like make it somewhat thinner. So if I actually, like, let's actually have it here like this though. I guess like the black will be okay, like blue will be much more, no, much more visible. Let us say like for this certain, like, no, let us say for like this is your what, like your, let's say x1 comma 0, because each point on this, on y-axis, like, each y coordinate on x-axis will be 0. Let's actually drop it here, x2 comma 0, and let's also drop it here, x3 comma 0. Okay, let us say the estimated points. Now, like estimated points, we're gonna have x same but y will be different. What do I mean by that? So when I say x same, so I'm saying like, okay, keep the size same. Okay, but for each estimated value, I will gonna compare that estimated value with my original value. So if I say here, like this is your x comma, like let's say like this value can have what, like a coordinate of x1 and y1. Okay, so let's say like if I projected this values like, and this, let's say this sky blue value is a projected value or estimated value. Let us select this one. Okay, and this is your x1 comma y1 dash. Okay, so what exactly is going on here? So for x1, we've got two values. One is the y1 dash and one is the y1. So this y1 is your original value and this y1 dash is your estimated value. Okay, and now if I do this here like this, what exactly this is? This is nothing but your error. Okay, all right. So and similarly I can do like, you know, for this one as well like this, and let's say even for this, and so similarly, like, you know, for each of these values. Okay, when I go upward, basically I am predicting higher or I am estimating higher. When I go downwards, I am predicting or estimating lower. Okay, so now what if we've got these errors here? So those errors, what exactly those errors will be? Okay, errors will be what? E1, E2, E3, E4, and En. And here, EI can be represented as what? Yi minus Yi dash to the power 2. Because it's a squared error, right? This is a squared error. Okay, now let us say some of the errors, or I can say like average of errors. How exactly we can create an average or estimate an average? It's quite easy. I just have to sum all of these values, E1 plus E2 plus till En divided by n, right? And now further I can actually write it as 1 by n summation I is equals to 1 to n ei. Further I can rewrite this statement as 1 over n summation I is equals to 1 to n yi minus yi dash to the power 2. And this is your mean squared error. Okay, so what exactly this mean squared error is? Mean squared error, what exactly this is? So this is your average error in each estimation. Each estimation while predicting, or while predicting house price, while predicting the house price. Right, so if I rewrite this equation, so what exactly, so I'm just going to name this as cost, or this is also called a cost of an estimation. Any questions, guys? Like I would like to have a few questions here. It's been almost 40 minutes and I am drying my like throat out here, so I'm just gonna have some water. So you can ask me questions meanwhile. Come on, ask me questions. Yeah, sure. So mean error is average error. First, just try to understand this. First, try to understand what exactly the error is. So your error is nothing but the difference between your original value and your estimated value. And when we take the square of that error, it becomes squared error. That's it. And mean is nothing but the average. So how exactly do we calculate average? We sum all the values and divide the number of values. That is your average, right? So that is why the name, hence the name is mean squared error. All right, so you can see like, and also referred as cost of, like estimation here. Okay, is it clear? Alok, hi Naveen, hi. Okay, all right. So now, if we talk about this error, like I will not gonna go into the optimization of this error at all, but the cost, if I write here 1 by n summation I is equals to 1 to n, like yi minus yi dash to the power 2. This is the error, right? Okay. So can anyone here can tell me? Can anyone here can tell me? Just a sec. Okay. Can anyone here can tell me what I need to do here? Like, should I like? Don't you think like our objective is here? What exactly is our objective will be? Reduce the error. Like this is something we need to reduce, right? Right? Okay. So okay. So now how exactly, so here, if we talk about like for this one, I will gonna go back here. So what do you think like we need to tweak here? Okay. So based on, okay, so based on optimal values of weight vectors, okay, we can optimize our cost function, right? Okay, what is happening, right? Okay, so your cost function is that, and this is your mean value here, which we just saw. Okay, so now, okay, so now again, if I redraw that structure, so we have got this x1, x2, x3, x4, x5, and b, right? And we've got this neuron here, which we have named f. Okay, let us say it actually predicts what y dash, and this y dash will gonna go into the loss function L of y comma y dash. Okay, and this loss is what, like and our task is to reduce the loss through training. Reduction actually, like it's more of a gradient descent thing. I might cover this topic tomorrow. Might, I am not promising it right now because I need to check like what exactly the bandwidth will be, because this is quite an extensive topic to even discuss, like how exactly your model actually learns those parameters. But I can say you need to learn these weight factors here: w1, w2, w3, and w4, w5, and 1. Like these are the vectors you need to learn, and obviously this bias value as well. Okay, so now if I put it here, okay, all right. So now that was a single layered neural network which we just saw. Now let's see the notation. Notation, notation of an artificial neural network. Okay, so how exactly it will going to look like? Let's see. So in this case, you're gonna have this x1, x2, x3, x4, okay, and x5 and b, and you can have multiple neurons. Okay, I will gonna explain why exactly this is called a layer and everything. Let's see like this. It's too much actually. Only stick with the much better. Okay, so now each, no, each of this input can go into this, 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 and this. Okay, and I'm just gonna. It's a bit of a tiresome task, but I have to do it. I really hate it. Like you can see, like even my lines are not straight. So please excuse me for that. Okay, it will just gonna have the y, and this y will just gonna have the l y dash actually y dash and y. Okay, and now let's talk about the notation. So this layer is called input layer. Yes, Alok, I don't know, but I think you have a third eye. Honestly, I and if you have studied this topic or not, but you got this really correct here. Right. So yes, this is actually many-to-many relationship. If we look this concept entirely from the concept of sets and relations from mathematics, right? Like this is actually a many-to-many connection, right? Okay. Yeah. How? Okay. And okay. And now, like, let's say for this one. So if I say here, like, how many, like, can anyone tell me, like, in this, like, this is your, and when we stack one neuron over other, it basically becomes a layer. So this is also layer actually. This is a single neuron layer, sorry. And this is three neuron layer, and this is four neuron layer. Okay. So this is your layer number one. And this is usually referred as a hidden layer. Hidden layer 2, hidden layer 3, and this is your output layer, and this is your input layer here, right? And now, when we talk about this, right? So anyone can here tell me like how many parameters I'll be needing or how many weights I'll be needing here, like in this way, in this like in this entire uh, structure, like especially for this one, for the layer one. How many weights do you see going in? Like for layer one, how many values or how many weights do you see going in in the layer one? Just remember this in the layer one. This is the question to you guys. Come on, give me a number. 19, 18, 18, 19. How? 6 multiplied by 3. Yeah, exactly. Okay. So you need to learn these many parameters. 6 multiplied by 3, right? And obviously for this one, how many there will be? 3 multiplied by 4, 12. And this will be 6, sorry, 8, right? 4 multiplied by 2, 8, and here will be 2. So if we see like 18, 12, 8, and 2, so this basically becomes like 40. So you will gonna have 40 weights and biases, like not obviously not biases, you will gonna have if we reduce that number 40 minus 3, so you're gonna have 37 weights, right? And three biases like attached to it, like like let's actually not 37, but each will just gonna have it like this. Yeah, if we see like on three bias values, like not three bias, but not in a way, but I'm just actually seeing this value entirely for the matrix like preposition. Let's actually say let's actually write them as only 40 parameters to learn or parameters to tweak or come with. Okay, and this is your loss function here, like which we just covered, and this is your output layer, and this is called also as a fully connected network, FCN. Okay, fully connect. Why we exactly are calling it fully connected network? Because each of those neurons are connected with each other, right? Like each one of those, like no one is not leaving one behind. And we need to learn those weights on like which basically exist on on these edges here. Okay, and this is your artificial neural network, like also referred as an ANN. Okay, and we can literally have n number of layers. Like there is no number to it. Like we can like that. Like I guess like someone asked me, like I guess like how can we just the how many layers do we put into? This is totally experimental, Vidya, right? Totally experimental, depends upon your data set. Sometimes if you have less data and you have more layers, it will just gonna overfit. We will gonna see overfitting and underfitting in our next session, but this is totally subject to experiment. All right, okay, that's great. And now, so this is your ANN, guys. Okay, so now what we will gonna see, but in tomorrow's session will be this. So tomorrow we will be tackling with the TensorFlow, right? Like how exactly the TensorFlow you can actually use. And we are gonna see two methods there along with the TensorFlow. First will be the regression, and second one will be your classification. So we have to go on until last. What do you mean by along this? Like, yes, we you have to go to the last layer, obviously. Any questions? Yeah, I mean also the layer. I also mean the layer. Okay. So what you'll be studying tomorrow, we'll be studying TensorFlow. Like really basic TensorFlow. I'm not gonna go into the detail of any of those, but believe me, you're just gonna have a good tool to even to play with when these 5 day sessions will be done. Experimental, as you said, like we basically determine, we basically like play with those optimizers, learning rates, and also sometimes even feature engineering, right? So that is what is subject to experiment. Okay, Alok. So which I cannot cover in this last 5 minutes or 4 minutes which we have left right now. So sorry for that. We will not going to go into the experimental mode at all. We do have bandwidth here. Okay, so this is it for today, guys. So if you have any questions, please ask your questions here. I am happy to answer those questions. And yeah, let's actually chat for a bit. Any questions, guys? Any questions? Okay, and let me just. Okay, I hope this is clear. If not, just what will be the project about? Like it will be housing price, and also along with the classification, like digit classification. That's it. So for all right, TensorFlow is used with Google Colab. Yeah, it will be used with the Google Colab. Yes. So, how many of you here speak Hindi? Like, I would like to know. Like, someone actually was saying, like, "Hey, so speak in Hindi." How many of you actually speak Hindi? Wouldn't housing price prediction come under linear regression? It does not. It doesn't matter actually. You can literally solve that with the deep learning too. Till when we have to complete the assignment, you will be having 2 days, I guess, or 3. You have to actually check with that moderator. I do. In deep learning, what other alternatives we have other than neural networks? Other than neural networks, deep learning is totally based on, like, loosely, like on a bigger picture. Basically, you deal with different kinds of neural network, Vidya. Okay, it was me for Hindi. Haha. अब मैं भी हिंदी बोल लेता हूँ, ठीक है, शुरू से बोलता आया हूँ, बट अगेन यहाँ पे इशू ये है कि बहुत सारे स्टूडेंट्स शायद वो सदर्न पार्ट ऑफ इंडिया से बिलोंग करते हैं, और शायद उन लोगों को कभी हिंदी से मतलब समझ में ना आए, या उतना बेहतर समझ ना आए जितना उनको शायद इंग्लिश में आ रहा हो. मेरी इंग्लिश भी कुछ खास नहीं है. आई जस्ट ट्राई माई बेस्ट. इट वॉज मी फॉर हिंदी. वाई सर? वट वाई छाया? वट डू यू मीन बाय वाई? Okay, and tomorrow's session will be much better, I guess. Like, in terms of project and everything. Why Hindi? Yeah, just asking, just having a chat, I guess. Hindi. That is great. Okay. All right. So, hmm. Any questions, guys? Questions? Asking questions here. Okay. So, any questions? Just let me know. Yeah, we can. Right now, I'm not gonna get into the DD either because it's again a huge, topic to talk about. Kind of, because it's I can actually refer some of those like some of my sessions for the EDA in the community itself, but it's something that you need to take care of. Yes. Buy LSTM and LSTMs? No. LSTMs literally, Chaya. Huh? LSTM is a, I wouldn't say, but yeah, it does require some knowledge about, like RNNs first. And for the RNN, you have to have understanding about ANNs thoroughly, how exactly the optimization, like in back propagation actually works in those. And then you can go ahead with the RNN, bi-directional RNNs, right? So for even to understand LSTMs and bi-LSTMs, you ought to have some basic understanding of RNNs in the first place. So the answer is no. No, I will not. All right. I guess like we are done now. Thank you so much for joining in, guys. I'll see you tomorrow. I'll see you this time. And for the project and everything, and for the project or assignment which you may have been given, try to do or try to search everything on your own. I know like you can ask me questions later on, but try to do the research on your own. And for the EDA part, if even if you keep EDA part as minimal as possible, that is also fine by me. Just try to be observant, like try to put as many observations as you can. That will be EDA for me, and try to plot them out. That's it. You don't really have to go crazy about it. Okay. Thank you. Good night. Good night, Mansoor. Good night, Syed. Thank you so much for joining in again. Bye bye. And मिलते हैं कल वापस से, ठीक है? Please join in again. Thank you. Thank you. Bye.